Okay, welcome. Michael Wickerson. Been a long time since I did some of this work, so we're just going to jump right into it. I'm at script 17, which is higher order derivatives. I actually think I've already done that, so I probably am going to transition of this into, let me just take a look at my Python files from last year. Um, we can look at antiderivatives and um, indefinite integrals. I think that's what we'll do, or we can do differential equations, initial value problems. But I think I'll do antiderivatives and indefinite integrals. So I'll copy that, and now I'll jump back over here to what we have, Rhino C# script editor. If I could just leave this screen, get my mouse back, and we will close this one, and we will save the higher order derivatives, and I'll show you how GPT can really make this stuff work. I'm going to do what I just said I'd do, but not call it 8 antiderivatives. We'll call this script because we're going from Python to C#. So this will be calculus, antiderivatives, and definite integrals. All these other files that I've been doing are on my Patreon, and that will be the title of that. And I'm also going to change our node in here from over to derivatives and definite integrals, and we'll number that. Oh wait, gene. So these are just single node formulas, and let's see if we can make them work. So we have that keyword, and I'll show you how simple this is. I have a pretty good GPT prompt going right here, and I can literally just extend this with a simple comment. I'll show you here. I'm going to prompt it with antiderivatives, anti-indefinite integrals, sorry, not derivatives. And what should I do? Please output the points. This is when I was doing the velocity. Great, but can you do a similar? Yeah, I'm just going to take this little prompt here, and I'm going to pop it in here and say, this is great, but can you make a similar style of a calculus surface C# script using the concept of calculus velocity and acceleration? Well, we don't want to do that. We just want to change that over as if we're reading a textbook. Antiderivative indefinite integrals, and please write it out in full. So let's just hit that and see what happens. I have made tens of thousands, if not hundreds of thousands of lines of script in C# and Python with GPT-4 for the past couple of months or more, and it's been just outstanding. So here it goes. It's writing up a nice little script. We could look at it in detail. We could read it in English, create a visualization of antiderivatives and indefinite integrals. It's going to show us the formulas it wants to apply. It's going to give our inputs, start, end resolutions, and our outputs will be function and antiderivative curves. So we're going to have two curves as geometry is coming out. It's going to really write a nice pseudocode. It will put in the formulas, and we are outputting as those terms, function curve and antiderivative. We'll have to remember those two because we have to actually type those in as outputs in the C script node editor. So I'm going to copy that code. I'm going to jump back over to the new script editor, and I will just pop in our script and run it. I should have a couple of outs objects right here, and there they are. And this is the way it always works. I need a start and I need an end. We're going to do a start at -1. We're going to go to 10. And I think I'm going to start this back at -10. As soon as we go to negative, we get this little added 1 there for some reason. And there we go. We're going to go from -10 to 10. And now we just have to type in our function curve as our output. After getting rid of our two objects, this is just the default that works, and I've had really good experience with it. I will show you debugging as we go. This is literally as simple as this gets. You'll see that there's a couple of bugs there that the old lines stay just going to nowhere. We'll have to delete those. We're not looking at vectors, we're actually looking at curves. So we can actually put in an actual curve, but let's get the antiderivative curves in here as well. Not as output B. And it doesn't always work out this easy, but let's run it. And there we go. And now we know we want our params to come out as curves. 1 and 2. It's going to be a pretty simple script to start. You can see it's already there. And there is our initial. That's interesting. Oh, it's just because I've only got 10 lines. I'm going to have to take my resolution up. I'd say let's take it up to 200. Should be nice. Let's bring it up to around 126. And there you go. You get your derivative and integral on top of. So pretty nice antiderivative and indefinite integrals, and you've got your simple geometries to start. And you can always put those into entwine or merge node, or you can just pop them in and see what they look like. You cannot put multiple things into a param viewer, but you can put multiple things into a panel. It's just Grasshopper. So you should shift to Grasshopper 2.0 and see what happens. So there's a little script. It's a little parametric, but let's jive this up a little bit. Let's copy all this as an iteration down here, and let's go back to, we call this B if we want, and I want to get rid of that old name for it, and I want to get 18B, and now we're going to try and do something a little better with this. We'll just do a quick save, and let's see what it can do if we just give it a little coaxing. Great, but can you output calculus surfaces with this script and make it more complex with more inputs parametrically, please? And then I'm always nice to my thing. If so, please write script in full. And that's about it. So if I didn't make too many typos, we'll just see what it wants to do. It's going to visualize it, the concept further, the values, over another dimension, consider the simple function on a circle, surface, and we're going to regenerate because something bugged out on us, which is fine. This has been a wonderful transcript. If anybody's interested, I have it here, ready to copy the link if I wanted to grab it, because I haven't used any image prompts. But you can see I've got an awful lot of calculus in here, starting with my first text prompts to get it running, and just endless scripts generated in very, very short periods of time. So we'll just take this one up once, and this is basically what I'm doing when I have time. This summer, if it's a real interest, I'll have a double in, and a double in. ABC, I'll have an antiderivative function surface out, and I'll have an integer for dissolution, and resolution, and I'll have the start and end. So that should be pretty nice. Just take a look at the inputs, just as if you were writing your own C# development plugins. But I'm going to say it's better without even looking at it. I'm going to copy it, and hopefully we get the same type of exercise without too many bugs. Not that I would mind getting a bug right now. So let's jump in here, and let's copy the script in, and if we run it, we should get our outs. There they are, out object, out object. We are going to want some numbers in, so I'm going to grab this one, and I'm going to copy it there, and I'm going to copy it 2 more times for A, B, and C, and just mix that up. There we go. I'm going to want my start of X, and I'm going to want my end of X, and I'm going to want my, and I've got a C start, and I'm going to actually make sure that's end is here. I'm going to copy these 2 parameters here for start C, and I'm going to have the same resolution on the next one, and I might just want to plug it in, but it's nice to get these all organized. And we can take off our 2 objects, and our 2 objects need to be our outputs, which you can look up at the start or you can look down at the bottom. You're going to want your function surface. I think I'm going to get a little bug here with the surface, but you'll see what happens. Function surface and antiderivative surface. Hoping I get a bug. Let's just see what happens, and let's clean it up a little bit here. There you go, nice little script, and it worked. So all we have to do is override the old values that are coming out. Curves will not cut it, so it's probably a good practice to use only geometries, which should take meshes, but you don't want to set the meshes because you might not want a mesh. So we have a surface and a surface, and this is always revealing and exciting. We've got one, and we're going to take these two, untrimmed surface, untrimmed surface. If it's running, we're going to take a look at it. What do we have? And we're going to zoom back out. And it's very, hang on a second. Let's get our settings a little better. Not -10. Let's bring these out. Let's see what we can grab. We're going to want our Z start to show a form. There you go. And this one's fine. And there you go. We've got some pretty big stuff. So let's bring that one down to here. Let's bring that one down. And we're just taking a look at the surface and seeing if we can wrap our heads around it. And all it's done is really extruded it and done something kind of fancy. So let me zoom extends all. It's going to make it very small. I don't want to focus in on the center, and I'm going to make my numbers. I'm going to do my resolution high. I'm going to make my my range much smaller. I think -3 to 3, and we'll go -3 or -4 to 3, and A value we're going to bring down. There we go. Oh yes, lovely, because these are the variables at the front of the. Oh, I do like that. That's pretty interesting. Nice. And I think I'm just going to do a little loop, see what I've got going on. I can panel around. Nice shape. And if I bring my B up, let's keep it kind of simple, ribbon-like, and there we go. I can play with my C value to change it up again. So I'm not just playing with the function surface, I'm playing with the antiderivative surface as well. Pretty powerful tool for getting a hold of curves, and not too hard to make the surface, just an extrusion, so nothing too fancy. And this is a wonderful way to come up with new designs. GPT will help you, math will solve all your problems, and let's just jump in here and do a zoom extends off, awfully small because you've got some extremes. There's the top view, there's the perspective. This is the side right in the center, which is an awkward little shape, but this one you're kind of seeing what's happening on the antiderivative surface. Pretty fun stuff. That's all you have to do. Pop this down here, maybe make it so you can see what's going on as titles of the scripts. And I like to expose the script, make this as small as possible, and put it down here. And then I like to give a hint at actually, I might just move this one over, and this one I might just want to make a little bigger. There's two scripts here, the easier one at the start, and the more complex one, the more parametric one at the bottom. And then, in any case, I might just go back up to what this script was for GPT surface, put it in here for a screenshot. You can see that GPT came up with this answer. I'm just going to shrink it a bit. Actually, I'm going to shrink it there. It's not all there. Let's see if I can't pull that down. Yeah. A little breakdown of what it is. It's not everything, but gives you a sense of what's going on. I can get it in there. There we go. Create a more parametric skip that visualizes the calculus surface that integrates a higher complexity and flexibility. And this is a wonderful way to come at new curves and new surfaces if this is actually your bag. And I'm doing this, and I'm just kind of going through my first or second year university calculus book by text prompts. And once you get this stuff up and running, it's pretty incredible because it writes itself with very little prompting. If you are interested, all these files are online, and I can actually give you access to the transcript if you wanted to walk through and see how I've done a whole slew of these forms as we go. While I have this one here, think that was it. No, a little farther down. There it was. I will just take a nice screenshot while we're waiting. Snipping tool. I'll save it. Rectangular. And I'll put this on my drive. And we will call it file save as. I guess we better call it what we want to call it. We'll call it anti. Give it this name. Was it 17? Or was it 18? I think it was 17. I could be wrong. Anti-derivatives and go higher order. I think I had a higher order, but I didn't save that one, so this was the 18. Didn't make a screenshot of the higher order derivatives, but that's all right. This will be the anti-derivatives and indefinite integrals script at 18. So I'll save that one and put it online. And tell me if you're excited about this and this is stuff you want to see more of. It's not very hard to get back into it. I just save the file, and I'll probably go back and see what my next one will be. So if I go back into single variable calculus, differentiation, antiderivatives, and integrals, I'm actually past differentiation, and we're going to go into either elementary transcendental functions, and we will start with circular trigonometric functions, which will kick us off with cosine and special angles, and go all the way through the sine law. So that should be pretty fun. So thanks very much for watching. I'm going to hit pause and put this video up. Let me know if you like it, and I'll keep doing it. Ugh.